Do we have everybody we're expecting?
Well,
In reality?
in reality.
Okay. So, besides John, yeah, this way. I'm not going to yell at you if you're on your phone, just don't be on it the whole time, please. Who knows anything about anything with sound or lights?
Lights sound on and they turn off.
This is going to be a long day.
Sound.
Okay,
There's a switch to make them go bright and dim and.
get comfortable.
Oh, I'm not here for that.
Oh no, I'm just telling you to get comfortable. You look pretty comfortable.
I am.
Oh,
Okay.
it's
Oh.
sound thing. Decibels have some AC that's never mind.
Okay,
Is
since
that
you mentioned
TV air-
decibels, do you know what a decibel is?
It's like the measure of the volume at
A fraction of a whole.
For your purposes, a single decibel is the threshold of change in which you can hear. So anything less than a single decibel change, you won't be able to hear the difference. And for every 3 decibels, it's a doubling of how loud it seems. So if I'm talking at 20 decibels and I start talking at 23 decibels, it sounds like it's double the volume. And I don't actually know if that was 3 decibels difference. So, let's start, since we defined decibels. Hertz is frequency. So pretty much vibrations, a pendulum, anything can be described in hertz if it has periodic motion. Do I have you looking at me like deer in headlights, or are you getting any of this?
I get it.
You sure?
Yeah.
You don't? Ask
John,
But I get it.
got it, thank you. So you got hertz.
Right now.
Human hearing, 20 hertz, all the way up to 20,000 hertz or 20 kilohertz. So everything from thunder, which can go down below you, you will feel that in your other organs, like your lungs, you'll feel the vibrations, but your ears can only hear down to about 20, 18, 22 hertz.
Chinese class is being held now in room C205.
Alright, we're going to disconnect that. Alright, so when you get sound into a microphone, which I believe I brought a prop. In there, you see that little piece of plastic?
Mhm. Yeah.
See that piece of plastic going over inside? That's the diaphragm. This is a dynamic microphone, and it works just the opposite of the way a speaker works. So a speaker works by having electricity go to it, and then it vibrates. This sound vibrates and sends electricity out. Questions? Go ahead, ask.
No, I don't have any.
No?
No.
Alright. Alright. Sound, or audio in this case, since sound is just in the air, audio is sound and in the wires and such. Sound operates on AC voltage, typically. Otherwise, you'll just have your speaker pushed out. So this would actually be the movement of the speaker or the microphone. So you put that voltage through it, the speaker's going to go. Yeah, the sound effects are wonderful. If you were to put this voltage through it, which is just DC voltage, direct current, you'll just get the diaphragm sticking out. It won't move back and forth at all. That's not all that useful to know, but alright, signal flow. Start with the mic, beautifully drawn there. And then it goes, the microphone turns it into a voltage, like an alternating current, and then that goes to the mixer. Mixer here, this is the input, it takes it down to the preamplifier, which brings it up to a useful voltage for the mixer to play with. It's too small of a signal when it's directly from the mic without a preamp. Then it goes through the equalizer, which allows you to change the presence of certain frequencies. So say you wanted to get rid of all the low frequencies below, say 200 hertz. One of those knobs would do that. And then if you want to peak some, bring some frequencies out, you can do that with that as well. Then it goes typically to the pan. We're going to ignore other random things. The pan, which switches it to your left or your right output. And then it goes to the fader, which is your little slidey knob for volume. Then it goes to your output faders, which then go to your actual outputs. Yes, sir.
So the equalizers, they get rid of any background sounds?
No.
Background noise?
You can filter out certain frequencies. So say you have a lot of high-end noise, say everything above 12 kilohertz. You can turn that knob all the way over and you'll kill all the frequencies, say, above 12 kilohertz. But then you also lose a lot of other definition that you have. So the human voice really is between, say, 250 hertz and 1000 hertz. But there's overtones in everything. So that's a lot of 12 kilohertz and even up to about 15. You got to be careful when you're cutting entire frequency ranges. So. I finished drawing. Oh no. Alright, then you go from your mixer. Typically, we'll just say to you.
What's Amanda's last name?
You go from your mixer to your amplifier. There are three. I like that you're actually writing notes. I like that.
Yes.
Okay. Her notes are bigger. I can see them better from here.
Hers
She's
are
drawing
just
pictures.
names. She just says names. The plastic thing.
The plastic.
Microphone.
The mic?
Oh. Yeah.
It's metal. It's nickel.
You just said plastic though.
Oh,
She's talking or she's talking?
the plastic diaphragm.
Yeah.
Okay.
I know.
Okay. I'll take your word for it. What the heck was I gonna draw now? Oh. Maybe I'll get the right letter in there.
Really? Is Mr. Poppins taking Chinese?
No, he's having a very important meeting.
Really?
Really super Chinese.
So what? Is Mr. Poppins really taking Chinese right now?
Oh, he is?
Yeah, he already knows it though.
No, he
Doesn't
doesn't.
he?
No, he knows a little bit.
He knows Mandarin. It was.
Not maybe it is not Chinese.
Maybe it's a
Yeah.
foreign language.
Oh, I didn't know. I didn't know Dr. Abel had a name.
He's learning Chinese.
I mean, it's not very good. Is he learning Chinese?
It's his whole school. She's going to go by Chinese.
Yeah.
I can't speak Chinese.
Really learning Chinese? Oh, I don't know. That
Do you
would
know
be-
Chinese?
Ni hao. Yeah.
Ni hao.
Hello.
Oh.
Ni hao.
Ni hao. Blood Japanese. Ni hao. Need to join the meeting.
Okay,
Go say.
we have. Thank you. We have 3 different signal levels. Microphone is very quiet. What comes out of here is a very low voltage. So you can't do too much until you put it through a preamplifier. It's about negative 50 decibel units. So you don't really need to know the numbers except for line. So you put it through a preamplifier, or say you're taking your computer headphone output or out of a CD player or something. What you need some?
What does that say on the line? Like 10 to what?
Oh, negative 10 to positive 4. That is what you'll get out of, say, the line out on a computer or the back of a CD player deck or your iPod, although that's a little hotter than that. Consumer products are always negative 10 dBu, which means they're quieter than professional products. So something, say, that you typically have in a rack will be positive 4 decibels output. And then you put your line output to a power amplifier or a speaker that has an amplifier in it already, and that amplifies it to anywhere above 10 dBu, depending on how loud you are. So you go to your power amplifier with your line, you jack it up to a useful level to hear. Once you put it to your speaker, speaker turns that voltage into sound. So it's the exact opposite of what just happened over here with the microphone. If I wanted to, I could reverse wire this and make it a speaker. You can't do it with all mics and all speakers, but for dynamic mics and pretty much most speakers, you can do that. That's how they get two-way radios to work. They just have one speaker in there. When you press down the button, it becomes a microphone. Do I have questions at all in the moment? Please ask anything. Alright. There are 3 types of microphones and 1 subtype.
I have a question.
Yes.
How does all of this have to do with the stage crew? The sound?
Yeah, this is
the mic?
sound. This is you're not just playing with stuff. You're learning stuff.
Oh, okay.
So rather than just pressing buttons, you'll know why they work.
Okay.
You don't do that as well.
Yes, but
That's a different day.
yeah,
Okay.
and I need to explore the lights a little more because I just got a DC adapter for the light controller
Okay.
because apparently that was lost at some point. And I'm also looking into dimmer packs for the rest of our fixtures.
Okay.
So that's likely to change. Right now, it's very simple. There's not a whole lot of theory to go on right now because it's circuit breakers.
Right.
All right, so 3 types of microphones. These 2 are the most common. These are typically very old. This is a dynamic microphone. Works the same way as a speaker. Just what we went over. It takes the sound waves and every vibration past the coil in there makes a voltage. That's translated into sound once you go back through the signal flow. A condenser microphone, they're a little special. They require something called phantom power or their own power source. Phantom power is 48 volts DC, which what that does is it levitates the part of the capsule in there that captures the sound, and then it measures differences between the 2 surfaces for figuring out what the sound is. But thing to remember with these is they always have to have phantom power or their own power source. Some of them can run on a 9-volt battery, some of them need a plug-in source. Ribbon mics are not usually seen. You'll probably never see one in high school. I've only ever seen one, and I went to college for this. Thing about ribbon mics, just to know, because you should know it, do not send phantom power, which you need for these, to ribbon mics. You will make them explode if they're old and not properly wired, which the old ones aren't. So write that one down, please.
When am I ready?
No phantom power to ribbon mics.
It'll blow up.
They'll smoke a lot and make funny sparking noises. So, technical questions, anything that comes to mind. Stupid questions, please.
Good notes, right?
Yeah. Not shaky, I like it.
Do you like her notes? Look at
I'm sure she'll just copy off of you. Yes.
Everyone does that.
You can't put phantom power to a ribbon microphone. Once we get to a mixer that's actually set up and everything, it's a lot easier to see what things do. Andrew, do you have any questions? Oh.
I appreciate being included.
Alright.
So,
Can I go ahead and erase some of this?
absolutely.
Yeah, just don't erase a single flow one part.
Don't erase
Oh,
things
okay.
slow.
Are we using headsets this year?
We're using whatever equipment I can find in the closet.
Oh,
Uh-oh, uh-oh.
Well, and we're looking at a new mixer and 2 hanging mics for the stage.
yeah.
I don't know what we're using for crew communication. Depending on what we do, it may just be, you know what the heck you're doing when you're paying attention to the show.
I got ideas, so. We have anything.
Alright. What was I gonna write?
Are we using Because some school districts with their musical productions use electric tape, or using that again,
Say again.
electric tape, the
Elec-
stage,
For spiking,
maybe.
for placement of people.
Yeah.
For that, we'll go ahead and get some actual spike tape for that purpose. It doesn't leave as much residue. What was I gonna write? It was excessively useful. Oh, I got it. Okay, there's 3 types of connectors. I can't make a screen with.
Oh,
There.
oh,
Guess that frequency. That's about 16 kilohertz.
oh. I'm sure the next door heard that.
Oh.
In fact, they were probably like, what are they doing over there?
Hmm.
I'm gonna go check that out.
Ah. Anyway.
Andrew, you look intense.
Making up the cast list.
Oh, intense. Yeah, I guess it is.
Some fun stuff.
So come asking me because of the cast. They were asking me who's in stage crew, and I kind of joked around right now. I said, don't ask me who's in the cast list because I wouldn't know.
I don't think it's
Guys,
that. Yeah, I don't-
get along.
I don't
Bless you. You're welcome.
That is not what it may look like.
Don't draw that on your paper.
I wasn't planning on it. Was it called blood?
Alright, 3 types of connectors. This is XLR. You know what that looks like. It's got 3 pins. The signal, the hot section of the signal where you are sending your signal to something else, in XLR will always be the male. It'll always have the pins there. The thing that's receiving the signal will always be the female. Yes, keep giggling, please. It's good for you.
Which one do we use?
Oh, okay. Which one do we use?
Yep.
Out of all of those?
Yep.
All of them.
Oh, okay.
This is RCA. That yellow, red, and white one.
Yeah.
This is RCA. I'm sure you've all seen this before. Don't have that in my pocket. Yes. This is TRS. This stands for tip ring sleeve. So you got tip, you got the ring there, and then you got the sleeve. That's TRS. Tip, ring, sleeve. And then you can also have tip, ring, sleeve. You'll probably never see that, but it's there. Like, sometimes you can have a third or a second ring on there. Glad I had that in my pocket. XLR is typically it is almost always the connector on a microphone. That's pretty much the industry standard. And then connecting to your mixer and sometimes your power amplifier, rarely to your speaker, you'll use XLR. TRS or sometimes just TS, where it's just tip and sleeve, which looks like that. It's very simple. That's what most people would consider a mono plug. Most people would consider the tip ring sleeve a stereo plug because you can send a stereo signal through that. Do I need to define stereo and mono?
Nah.
You guys good? Okay. Andrew, you good?
Mono one stereo.
Yeah. You'll almost always use TRS for going from guitars and other amplified instruments like that to, say, your amplifier or your board. And then a lot of times you'll use TRS for your output from your board to your power amplifiers, and almost always you'll have TRS from your power amplifiers to your speakers, if the amplifiers aren't in the speakers already. And RCA is typically the garbage that's on like your home stereo system. Some CD players, CD decks have them, and then you can also use an adapter like this for outputting like from a laptop or an iPod onto the board, because that's typically called a tape input, little old term. On XLR is the only cable that supports phantom power. Phantom power will always go through this. Not that you really need to know at the moment, but it's a cool thing to know. It'll always go through what's called just number 3. They're numbered 1, 2, 3. I'm not sure if I want to go into this in depth yet, but since you guys are here, might as well. This electricity is at 60 hertz in this country anyway. That means you'll hear a buzz like if you were to put a speaker in it before the speaker blew up. And they do actually blow up pretty spectacularly if you plug them into the wall. We should do that sometime. Yeah.
Let's don't blow up any speakers, please.
Oh, I got a few extra at home. Now, if you run your microphone cables along, say, a nice extension cord like this, you'll undoubtedly get a 60 hertz hum. That's I'm trying to find the humor. Enlighten me?
What? It's like a cord. I don't know. Sorry.
Alright, so if you run your say your speaker cables or your microphone cables along the same route as an extension cord or right next to where the wall power runs, you'll usually get a 60 hertz hum. In that case, there's not a whole lot you can do about it. If, though, you have an issue with the grounding of your mixer, there's equipment called a ground loop cut, where it just cuts out part of that part of the signal that's going through. I was going to go somewhere better with that, but I forgot.
We're gonna have to leave in like
That's
2
fine.
minutes.
Leave. Alright, then we'll just wrap up for today. So, there you go.
Is that it?
For today, I mean that's pretty much the basics. If any of you are interested in getting into sound like a lot more, like maybe even doing some of it in college, there is a book that I suggest you read. I'm going to try to bring it next time I come. But it's really awesome to have your own copy. It's the Yamaha Sound Reinforcement Handbook. So it's like $22 on Amazon. But it's one of the most in-depth books on sound for beginners, for professionals. I look at stuff in there occasionally too. So if you're that interested, go ahead and buy that. If not, I'm going to bring in my copy next time I come, if I remember, which is slim chance. So, any questions before I release you into the wild? All right,
Alright.
you are free.
Oh,
Ay, ay, ay.